everyone. In this video, let us study eigenvalues and eigenvectors. Eigenvalues and eigenvectors are abundantly used in the field of control systems, data science, AI and machine learning, and computer physics. Now let us look into some of the uses of eigenvalues and eigenvectors. If you can represent a system in the form of a linear differential equation, then you can use misuse of these eigenvalues and eigenvectors to find the rate of change or to maintain the relationship between the two variables. Sometimes we represent the information in the form of a matrix, and by these eigenvalues and eigenvectors, they characterize the information in the matrix. By choosing these eigenvalues and eigenvectors, we can get the key information about the matrix. It is used in the principal component analysis, and not only that, we can use this component analysis technique to extract to reduce the dimension space without missing the information. Eigenvectors and eigenvalues are used in the facial recognition systems such as eigenfaces. They are used to reduce the dimension of the space. By doing so, we can compress the data. They are also used for regularization, and they also can be used to prevent overfitting. Most of the time, whenever we gather the data, they contain large amount of noise. It will be very difficult to get a pattern out of this noise. In such cases, we can make use of eigenvectors and eigenvalues to extract the pattern. Most of the time, the information is hidden in the data set that needs to be extracted. So therefore, we make use of these eigenvectors in case of such engines and calculations. Nonlinear motion dynamics also makes use of these eigenvalues and eigenvectors, which can help us to understand the data better. Consider this figure. We have two vectors which are marked in red lines, and we are going to apply a matrix A, linear transformation matrix A, on these two vectors. They get transformed as shown in the second figure. You can observe here the vector in the vertical line is going to get reduced by half, whereas the vector in the horizontal line is double. The reason here it is multiplied by 2. The main observation what you have to make here is even the magnitudes are reduced or increased, but the direction of the vectors is not affected by linear transformation. Such vectors are called as eigenvectors of the transformation. Those vectors after transformation, if they do not change their direction, even though their magnitudes are going to change, they are called as eigenvectors. We'll consider a second case that is shown by the yellow line. You can observe here, after the transformation, its magnitude as well as direction are changed, and these are not called as eigenvectors. Eigenvector V of a matrix A is a vector for which this relationship holds good. Here lambda is known as eigenvalue and it is a scalar quantity. We will rewrite the equation as A minus lambda into I multiplied by vector V, where I is the identity matrix of dimension A. If A is a 2 cross 2 matrix, then I also should be equal to 2 cross 2. And you know that G cannot be zero vector. Therefore, this has to become 0, which means that here the magnitude of A minus lambda I should become 0 in order to satisfy this condition. Let us try to calculate the eigenvalues of a given matrix, which is defined as 2, 3, 2, 1. So let us call this matrix A is equal to 2, 3, 2, 1. Now it is a 2 cross 2 matrix. Therefore, I have to define I, which is equal to identity matrix, which is 1, 0, 0, 1. Now I have to get A minus lambda I, that is 2, 3, 2, 1 minus lambda into 1, 0, 0, 1. When I simplify this further, I get this as 2 minus lambda 3, and this is 2, and this is 1 minus lambda. And the determinant of this should be made equal to 0. So I get this as 2 minus lambda multiplied by 1 minus lambda minus 6 should be equal to 0. And when I simplify this equation, I am going to get lambda is equal to 4 and lambda is equal to minus 1. And these are called as eigenvalues. They characterize this matrix. Second step is to find the eigenvector. And we have got two eigenvalues. We'll take the first eigenvalue, lambda is equal to minus 1. Now it is a 2 cross 2 matrix. Therefore, we have two variables, and the two variables chosen are x11, x12. So when we simplify this, A into this can be written as A matrix multiplied by x vector is equal to lambda into x vector. What we have seen earlier, A V is equal to lambda into V. Now this x vector is defined as x11, x12. When I simplify this, I am going to get 2 into x11 plus 3 into x12 is equal to minus x11 on the right hand side. Further simplification will give me 3x11 plus 3x12 equal to 0, which gives me x11 is equal to minus x12. Let me take the second equation. The second equation is 2 times x11 plus x12 is equal to minus x12. Further simplification gives me 2 times x11, 2 times x12 is equal to 0, which gives me x11 is equal to minus x12. So you can observe here both the equations are same. So we can choose any value of for x12. Then we can get the value of x11. I have chosen x12 is equal to 1. Therefore, x11 is equal to minus 1. This even we can write this as vector v1 is equal, eigenvector v1 can be written as, if I choose x12 as minus 1, then x11 will be plus 1. or I can choose this as minus 2, then this becomes plus 2. So we'll take the second case. In the second case, we know that lambda is equal to 4. So you have a into x on the left hand side is equal to lambda into x on the right hand side. When I equate the two equations, I am going to get 2x21 plus 3x22 is equal to 4x21. So 2x21 plus 3x22, because this 4x21, when you bring it to the left hand side, you are going to get this as minus 2x21 plus 3x22 is equal to 0. So therefore, you have x21 is equal to 3 by 2 x22. So let me write the second equation. The second equation is given by 2x21 plus x22 is equal to 4x22. That gives you 2x21 is equal to 3x22. It is x21 is equal to 3 by 2 x22. You can observe here the same as the previous answer. So if I choose x22 is equal to 1, then x21 will become 3 by 2. So I have 3 by 2, 1. Multiplying this by 3, I am going to get 3, 2. If I choose x22 as 2, then x21 is equal to 3. So it depends upon what value you are going to choose for x22, then derive x21. And V1, V2 are the two eigenvectors. The first step is to find the eigenvalues, and eigenvalues can be found by the determinant of A minus lambda I equated to 0. So we have been given the matrix A. So I can write this as determinant of matrix A 4 minus 1 6 2 1 6 2 minus 1 8 minus lambda into, since A is a 3 cross 3 matrix, so I have to choose the identity matrix as 3 cross 3 matrix. That will give you, the resultant is 4 minus lambda minus 1 6, and this is 2 1 minus lambda 6. Then the last row will be 2 minus 1, it is 8 minus lambda, that needs to be equated to 0. So simplifying this, we have 4 minus lambda multiplied by minus lambda 1 minus lambda into 8 minus lambda plus 6, then it is plus 1, it is 2 into 8 minus lambda minus 12, then I have 6 into minus 2 minus 2 1 minus lambda. That should be equated to 0. When I simplify this further, I am going to get the resultant polynomial lambda cube lambda cube minus 13 lambda square plus 38 lambda minus 32 is equal to 0. Use your calculator to obtain the eigenvalues. The eigenvalues obtained are lambda 1 is equal to 9.27, lambda 2 is equal to 2, and lambda 3 is equal to 1.72. In the problem, he has asked you to get the eigenvector only for lambda value is equal to 2. We need to find the eigenvector corresponding to eigenvalue lambda is equal to 2. That is, here it is A, that is 4 minus 1, 6, 2, 1, 6, 2 minus 1, 8, multiplied by a vector x having the elements x1, x2, x3 is equal to lambda. In this case, lambda is 2 multiplied by x1, x2, x3. We'll equate the left hand side to right hand side. First equation is 4x1 minus x2 plus 6x3 is equal to 2x1, which will give me 2x1 minus x2 plus 6x3 is equal to 0. Second equation gives me 2x1 plus x2 plus 6x3 is equal to 0. That will give me, is equal to 2x2. That will give me 2x1 minus x2 plus 6x3 is equal to 0. Third equation is 2x1 minus x2 plus 8x3 is equal to 2x3. That will give me 2x1 minus x2 plus 6x3 equal to 0. If you observe, all these three equations are identical. So let me write it in the form of basis. x1, x2, x3 is given by x2 in the first case it is half 1 0 plus x3 minus 3 0 1. This I got it because 2x1 is equal to x2 minus 6x3. So x1 is equal to x2 by 2 minus 3x3. So if you see here x1, so x1 it gets multiplied by half, so half and minus 3, and x2 is 1, it is x2 equal to x2, x3 equal to x3. So two more equations here are x2 is equal to x2, x3 equal to x3. That is put in the form of a vector. In this case, we can see that eigenspace is a two-dimensional subspace. So I can write this as eigenspace is two-dimensional subspace. R square. So the basis for this eigenspace can be represented as two vectors half 1 0 minus 3 0 1. This is equivalent to multiplying the first one by 2, we have 1 2 0 minus 3 0 1. These are the two bases. Thank you. In the next video, let us study diagonalization of matrix.